So in 4.3, we'll be taking a further look at properties of logarithms. The first couple we've seen here, the first two, are just the basic representation of the exponential forms, some standard rules, that the log base b of b will be 1, meaning if those bases match, you've got a 1. Also, any base log of 1 will always be 0, and those just come from understanding the basic exponential representation. The next two we saw last section, a little more involved, but knowing that when you take a log base b of b to the x, if those bases match, you get your exponent. And then here, if you have a base to a power of a logarithm, but that base matches the base of your logarithm's base, then you'll get just what we call the argument, or the inside. So again, those are from last section as well, 4.2. The next three are new to us, and we have the product, quotient, and power rule. And these are used specifically when it's useful to us to do one of two things, either expand a logarithm or condense it. The idea being that we can take the logarithm of a product rule, m times n, and if it's convenient, break apart that logarithm into two separate logarithms. But notice they do not break apart into multiplication. The product of the insides leads to the addition of individual logarithms. So that would be called the kind of expanding the logarithm. Now, we also at times may have a benefit to looking at two separate logarithms that have the same base being added together and saying that these could be represented as a single logarithm, combining it, condensing it down to one logarithm with a product. So like I said, these can be used in either direction. Same with the next one, quotient, so division on the inside, can lead to separating them out with subtraction between them. And notice it is the numerator's logarithm minus the denominator's logarithm separately. But again, those can be combined into a single quotient. The last one, not so much about separating into separate logarithms, but a different way of writing it for convenience. The log of a base to a power, m to the p. Notice that p, that exponent, can actually be written out front of the logarithm as a different way to represent it. Might seem strange, but there is benefit to this. There will also be benefit to seeing a logarithm with a number out front and actually pulling it back inside of the logarithm as the power of that argument. So again, in both directions. So let's take a look at some of these three rules here especially. The first four are kind of just simplifying rules. These other three are the expanding or consolidating rules. So these first three examples have us using the properties of logarithms to write each expression as a single logarithm. Single meaning you are condensing it down into one term. So we see our first one with the logs base 2, and it's important those match. And if it's the addition between them, then our product rule says that the addition of separate logarithms with the same base can be written as the combined logarithm of those two multiplied together, 7 times 5. And so that would be log base 2 of 35. Now, I'm going to go ahead and put a box around that, and we will call that our exact answer. Sometimes we will approximate logarithms or exponents, but for us in this class, we won't bother doing that with these other bases here. If the base is 10, or if your logarithm is ln, or your base is an e, then we will go a step further and approximate using our calculators. So we'll get to that here very shortly. But for the next one, we have 2 ln of x plus ln of x plus 6. Notice this 2 out front, right? We're going to actually need to take care of that first before jumping into the plus, because our plus rule, our product rule, only works if it's separate logs, but there's nothing allowed to be out front of either of them, right? So here's where we can use this rule in this direction from right to left to allow us to get that 2 from outside the logarithm into it as a power, as an ln of x squared. So then we've got that. Now we've got ln, so that means log base e, so they are the same base, the product of them, so we can combine them into a single logarithm, ln of x squared times x plus 6, which we could even simplify a tiny bit by distributing x cubed plus 6x squared. Now, when you've got a variable in your argument, there's no approximating. This is just an expression. This is it. We're finished there. We're not going to try to break that down or approximate. We can only approximate logs of numbers, right? Specifically a value up there. All right, and the third one, we see a subtraction. We've got log, and there's no base written, so remember that means base 10. So log base 10 of these. So the subtraction will allow us to combine them, and it combines into a single fraction where it's always this is your numerator minus that is your denominator. So x plus 2 over x. And there's no simplifying to do there, so that is done.